So now we're going to look at geometric series and see, do they converge or diverge? If it converges, find the sum by using this formula. All right, so it's going to be geometric. It's easy to see if it's geometric if you have some multiplication and you have a number raised to a power. If you're not sure, you can go ahead and write out some terms and convince yourself. So if you let n be 1, you're going to get 5. If n is 2, you're going to get 15. If n is 3, you're going to get 45, and so forth. So that is a geometric series. So what is R? Well, we know A is 5 and R is 3. In fact, R is usually really easy to find because it is what's being raised to the power. So just knowing just knowing what R is will tell you if it converges or diverges. This diverges, and we cannot find the sum because you can just see the numbers are getting bigger and bigger. If I try to add those up, just not going to ever get there. Okay, so let's look at example number 2. Okay, again, geometric. If you're not convinced, write out some terms, but when it's in this format, you have something raised to a power, and it could be multiplied by 1 or any other one, but that's geometric. So R is going to be 2/5. It's what's raised to the power. So I know that is less than 1, so I know it converges. So now I need to find the sum, and in order to find the sum, I need the first term. And this is where you need to be really careful. You need to plug in whatever that value is. That's an index. Sometimes it starts with 0, sometimes 1, 2. Be careful. So if I plug in 1 there, A is going to be 3 times 2/5 to the first power. So that is 6/5. So my sum is 6/5 over 1 minus 2/5. Learn how to use your calculator or your brain, but that sum is going to be 2. And so we can say it converges, and it converges to 2. Okay, let's look at this one. Ooh, we had some negative ones, and kind of looks geometric. I have something multiplying, but that -1, that looks kind of odd. So let's go ahead and write out some terms. So when n is 1, that's going to be positive 1/3. When n is 2, we're going to have -1/9. And then 3 when n is 4, and so forth. So it's definitely geometric. What is R? What am I multiplying by each term? Not just positive 1/3, but -1/3. So this is a little different. And just writing out those terms, I know A is positive 1/3. I also know it converges because the absolute value of R, which equals 1/3, is less than 1. So I can find the sum. A over 1 minus R. So be careful with that negative. So the sum of this infinite geometric series exists, and it's 1/4. Look at number 4. And at any time, pause the video, you try to work them out, and then see if we get the same answer. So anytime I see this, I'm going to say, let's just write out some terms. When n is 1, I'm going to get positive, let's see, 9 over 16, I think. When n is, so this was n is 1. When n is 2, I'm going to get negative, I'm just not even going to write that out. It's going to be 3/4, 3 to the 4th power over 2 to the 7th. Then I'm going to get 3 to the 6th over 2 to the 10th, and so forth. That's ugly. So I have 9/16 minus 81 over whatever 2 to the 7th power is, plus 3 to the 6th over 2 to the 10th. What the heck am I multiplying by? Okay, what is R? So let's see. 9 times 9 is 81. Remember, that's 3 to the 4th times 3 squared is going to be 3 to the 6th times 3 squared. So I think this is going to be 9, but I have plus, minus, plus, so I need a negative. And on the bottom, let's see, I have 2 to the 4th, 2 to the 7th, 2 to the 10th. So this is 2 cubed. So that's negative 9 over 8. Does the series converge? Well, r is equal to negative 9/8. The absolute value of r is positive 9/8. Is that less than 1? No. So we can conclude it diverges and we cannot find its sum. The next type of special series we're going to look at is called a telescoping series. What happens is that you have a positive, negative, and you have terms that add to 0. If the last term approaches the value of 0, then we can find the sum of the telescoping series. So that's what we're going to look at now. First of all, you have to determine if it's telescoping, and again, it has a very distinct pattern. And then, does, of course, the series converge or diverge? In this particular type of series, if it converges, we actually can find the sum. If it's geometric, we're going to be able to find the sum. If it's telescoping, converging, we can find the sum. And that's going to be almost it. So let's look at this example. Let's see, is it telescoping? Well, the easiest way is to just go ahead and write out some terms. So I'm going to let n equal to 1. So I get 1 over 1 minus 1 over 2. And of course, remember that sigma, this big O thing, that capital Greek letter means to add, so that's where I get this plus sign here. Then when n is 2, I get 1/2 minus 1/3. Then I get 1/3 minus 1/4. Keep going, and I'm going to have 1 over n minus 1 over n plus 1. So is it telescoping? Yes, it fits exactly this pattern here. That's going to add to 0, that's going to add to 0, that's going to add to 0. So what are you going to have left? You're going to have this term, and you're going to have this term. So we're going to have 1 minus 1 over n plus 1. Well, what happens as the limit, as n approaches infinity of this series? We get a value of 1. So it does converge, and its sum is 1. Let's look at this example. Well, right off, you don't see a minus, so how could it possibly be telescoping? We could write out some of these terms and see, well, might not be able to see a pattern. If I just let n be 1, I would have the natural log of 2 over 1 plus the natural log of 3 over 2 plus the natural log of 4 over 3, and so forth. That kind of looks like maybe it diverges. Don't really know. But could we use some properties of logarithms to rewrite this? Yes, you could. So if I have this series, kind of left out that natural log. I could rewrite this as the series, as n goes from 1 to infinity, of the natural log of the numerator minus the natural log of the denominator. Remember, the natural log of a divided by b is the natural log of a minus the natural log of b. So now at least I have that minus, so that may be telescoping. So let's again write out some terms. So we would have the natural log of 2 minus the natural log of 1 plus the natural log of 3 minus the natural log of 2 plus the natural log of 4 minus the natural log of 3. So just kind of taking those and subtracting, keep going, and we would have the natural log of n plus 1 minus the natural log of n. Well, it looks telescoping. Let's see. We have some terms that are adding out. That adds out. That adds out. That's 0. But what's going to happen? What's going to happen at the end? Are you going to have some terms left? So eventually the natural log of 4 would be canceled out, natural log of 5, but what is it going to cancel out with, and what do you have left over? Kind of hard to see like that. What if I write it a little bit differently? And of course these are all added up. Well, you can still see those are going to reduce out, but eventually when you get to the end, you're going to have this left. So you have this left, which is 0, but you're still going to have that term. And what happens as the limit of n approaches infinity of the natural log of n plus 1? Does that limit exist? No, it does not. So this series is indeed a telescoping series, but it does not converge. It diverges, and that's because really these terms are not getting smaller and smaller. So let's look at this example. I see a sigma, so it's a series, but how am I going to know if it converges or diverges? It doesn't look telescoping. I don't see a minus. It doesn't look geometric. So let's just start writing out some terms. So we'd have 6 when n is 1. That's going to be 1 times 3. Then I'd have 6 times over 3 times 5. 6 over 5 times 7. 6 over 7 times 9. Keep going. There's no minuses. I can't tell you. Is it converging or diverging? What could we do? Well, let's go back to partial fractions. So if we have 6 over 2n minus 1 times 2n plus 1, we could decompose those fractions like we did a few chapters ago. So multiplying through by the least common denominator, we're going to get 6 equals a times 2n plus 1, b times 2n minus 1. Let's see, if I let n equal to negative 1/2, that's going to be 0, so I have 6 equals b times this value, so I have 6 equals b. Let's see, that's going to be negative 2, so b is negative 3. If I let n be positive 1/2, that's going to be 0, so I have 6 equals a times this value, so that's going to be 2a, so a is positive 3. So all of a sudden, this series becomes this series. Let's see, a is 3 over 2n minus 1, and we have a negative, so that's minus 3 over 2n plus 1, as n goes from 1 to infinity. That possibly could be telescoping series. So now let's let n equal to 1. So let's see, I'm going to have 3 over 1 minus 3 over 3 plus 3 over 3 minus 3 over 5 plus 3 over 5 minus 3 over 7 plus dot 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 3 over 2n minus 1 minus 3 over 2n plus 1. Well, these certainly would cancel out. In fact, the only terms that you would have left is the first one and the last one. So let's see, that's the limit as n approaches infinity of 3, that's the first term, minus 3 over 2n plus 1. What's going to happen? That's going to go to 0, so therefore the series converges and its sum is equal to 3. So telescoping series, not always obvious.